Hello guys, this is Avram and I will be explaining the K-means clustering algorithm and the labeling of the states for the second project in computer applications. The first step before we implement the core body of the K-means algorithm is the normalization of the parameters of voltage and angle. This is important because they must lie in a space between 0 and 1. So that each state has equal importance and the algorithm will give more accurate results. To do so, we have implemented the method normalize values, which basically the first step is to find the maximum and minimum voltage and angle from the bunch of states that we have collected from the SQL database. The next step for the normalization is that we are utilizing the min-max method for the normalization of the parameters, and as a result we have all the voltages and angles laying in the space that we have mentioned before. The core body of the K-means algorithm, the first step in the core body of the K-means clustering is the creation of the initial points of the centers. To do so, we are implementing the random partition method so that we can get more accurate results. The random partition method, what actually does is that assigns in each of the 4 classes that we have a random number of an equal number of states, but in a random order. By doing it so, we are forcing the cluster centers to move much closer to the position of the states that we have, and so that the results of the K-means clustering procedure will be more accurate. The K-means clustering method is implemented in the method implement K-means. We have the normalizing of the parameters and creation of the random centers, and then the next step is to determine the clusters. The clusters are determined by calculating the Euclidean distance between each state and the position of the 4 clusters. For the cluster that we have the minimum distance, we assign the state to each cluster to do, and the procedure continues so on. Another important function that we have in here is check if empty method. The method actually checks if a cluster has 0 values inside, 0 states inside. If there is a 0 state, then we assign the state from the cluster that has the maximum values. We assign it to the class that has 0 states. To do so, we are forcing the center of the previously empty cluster, to move much closer to the position of the states. And the last part is to define the new center position based on the assigned states that we have used. The algorithm stops when the distance between the initial position of the center and the last position of the center are below a specified tolerance we give in here, or we have reached the maximum number of iterations that we can specify through the GUI. The next step is to label the cluster. Before we label the clusters, we are or normalize the values of voltage and angle to their physical ones, and then we create an object of the label state class. The label state class handles the three methods that are utilizing in the labeling of the clusters. The first one is the label generation outage. For the generation outage, we assume that when there is a generator outage in each of the 3 buses of the system, then the line that connects the generator bus in its adjacent will have 0 or very small voltage drop due to the fact that there is no power flow in the line. So what we do is, for the 4 clusters, we calculate the voltage drop in each of the 3 lines between buses 1, 4, 2, 8 and 3, 6, and we calculate the mean value for the voltage drop for all the states of each cluster. So basically what we do here for the cluster that has the minimum voltage drop, we assign it as generator outage. The next labeling procedure involves the label of the cluster that has line outage. Similarly with the labeling of the generator, in the line outage labeling, we calculate the voltage drop between each line that connects the buses in the system. We believe in this case that when a line is out of order, then the voltage drop between the previously connected buses will be greater, because the current will have to find an alternative path which involves a greater resistance, and that means that the voltage drop between the buses will be much higher compared to the case that the line was healthy. So we calculate the voltage drop in each line of the given system, and then for all the states of each cluster we calculate the mean value of the voltage drop for each line. Then the case involves that for the cluster that we can find the maximum voltage drop, in this case, we assign it as a line outage cluster. And finally, the labeling of the load rate, we assume that when we have a high load rate in a power system, then the current that will flow through the lines is much greater, which means that we have a greater power, greater losses, and that the voltage in each bus will be smaller compared to the case we have low load rate and the losses are smaller. So for each state of the system, for each state of each cluster, we calculate the mean voltage of the bus. And then we calculate the mean voltage of the bus. For the cluster that we have, we can find the minimum, the maximum mean voltage in each bus. We assign it as a low load rate, and for the cluster that we have the minimum voltage in each bus, we assign it as a high load rate. The last step in here is in this part of our algorithm where we check if two clusters have the same label. Basically, this is done because of the position of the states in each cluster. To do so, if the system finds something like this, then we are forcing the algorithm to repeat again so that we can get much more accurate results. Thank you, and now Haris will present you the KNN clustering.